One of the fastest growing companies in the AI chip race does not make GPUs. It makes memory. China's Yangtze Memory Technologies, better known as YMTC, is moving toward a Shanghai IPO that could raise about $4.9 billion. Its parent company, CCSH, has filed to list on China's STAR market, and the timing is revealing. AI data centers are creating huge demand not only for processors, but for the storage systems feeding those processors. NAND prices have surged, enterprise SSD demand is rising, and YMTC's global market share has climbed rapidly. The strange part is that YMTC was supposed to be constrained. The United States placed the company on the Entity List in 2022, restricting its access to advanced American semiconductor technology and equipment. Yet 4 years later, YMTC is expanding factories, improving yields, increasing domestic equipment usage, and pushing deeper into the AI data center market. So the real question is no longer whether China can make competitive memory chips. It is whether restrictions designed to slow China are now helping create a more independent Chinese semiconductor supply chain. To understand why this matters, forget GPUs for a moment. When people think about artificial intelligence, they usually think about NVIDIA accelerators doing trillions of calculations. But a modern AI data center is constantly moving enormous quantities of information. Model files must be stored, training datasets must be retrieved, checkpoints must be written, databases must feed agents, logs, embeddings, user files, videos, and generated content all have to live somewhere. That is where NAND flash comes in. NAND is the non-volatile memory technology used inside SSDs. Unlike DRAM, it keeps information when power is removed. It is slower than high-bandwidth memory sitting beside an AI accelerator, but it is dramatically cheaper for storing huge amounts of data. And AI is consuming more of it. Counterpoint Research estimates that the global NAND market reached a record $46 billion in revenue during the first quarter of 2026, roughly 3.5 times the level from a year earlier. Enterprise SSDs used in servers accounted for around 43% of NAND demand, and Counterpoint expects that share to exceed 60% by the end of the year. That is a major shift. For years, NAND was heavily associated with smartphones, laptops, USB drives, and ordinary consumer electronics. Now, the fastest growing customer may be the AI data center, and that change arrived at exactly the right moment for YMTC. Counterpoint estimates that YMTC increased its global NAND revenue share from roughly 8% a year earlier to about 13% in the first quarter of 2026. That puts the Chinese company close to established international suppliers including Micron, SanDisk, and Kioxia. A company created only a decade ago is now fighting for a position near the top of one of the semiconductor industry's most important markets. But market share is only one part of the story. YMTC's real weapon is an unusual manufacturing architecture called Xtacking. Traditional NAND manufacturing places memory cells and much of the supporting logic together inside the same structure. YMTC takes a different approach. It manufactures the NAND memory array on one wafer and the peripheral logic responsible for functions such as data input and output on another wafer. Then it bonds the two together using enormous numbers of tiny vertical electrical connections. Think of it like building the storage part and the control system separately, optimizing each one for its own job, and then stacking them together. YMTC says this allows the peripheral circuits to use more appropriate logic processes while freeing more area for memory cells. The company also claims the architecture can improve I/O speed, increase bit density, and shorten parts of the development and manufacturing cycle. That design has helped YMTC continue increasing NAND density even while facing restrictions on some of the most advanced manufacturing equipment. This is important because semiconductor competition is often described too simply. The common assumption is that whoever has the smallest transistor automatically wins. Memory does not work quite that way. Modern 3D NAND grows vertically. Manufacturers stack many layers of memory cells on top of each other, allowing greater storage density without relying entirely on shrinking everything horizontally. That creates room for architectural innovation. YMTC's strategy has been to exploit that room. Its newer NAND generations use Xtacking 4.0, while earlier commercial products already reached high I/O speeds and dense 3D structures. Reuters reported earlier this year that YMTC's technology is now considered increasingly competitive with major global rivals. But technology alone would not explain what is happening now. Scale does. Reuters reported in April that YMTC was planning 2 additional fabrication plants beyond another facility already nearing completion. Its existing factories have combined capacity of roughly 200,000 wafers per month, while the new facilities could eventually add hundreds of thousands more wafers of monthly production. Once those factories ramp, YMTC could dramatically increase the amount of NAND available inside China. And this is where the geopolitical story becomes much bigger. For decades, China has imported enormous quantities of semiconductors from foreign suppliers. Memory chips from Samsung, SK Hynix, Micron, Kioxia, and others have been essential to Chinese phones, computers, servers, and cloud infrastructure. The AI boom makes that dependence even more uncomfortable. If Chinese companies are building their own AI models, their own accelerators, their own servers, and their own data centers, but still depend heavily on foreign memory, then the supply chain is not truly independent. YMTC gives Beijing a domestic alternative. TrendForce says the company has been shifting toward higher-end enterprise NAND and AI-oriented storage, while increasing supply chain localization. Some of its newer factories are expected to use a growing share of Chinese semiconductor manufacturing equipment. That does not mean China has eliminated its dependence on foreign technology. Far from it. Advanced semiconductor production still relies on an extremely complicated international ecosystem. Lithography, deposition, etching, metrology, packaging, chemicals, design software, and specialized components come from different countries. But every percentage point that can be localized reduces the effectiveness of external restrictions. And this creates a paradox. U.S. export controls were designed partly to prevent Chinese semiconductor companies from easily accessing cutting-edge technology, but those same restrictions also gave Chinese firms a powerful reason to redesign their supply chains. When a foreign machine is unavailable, there is suddenly a guaranteed domestic customer for a Chinese alternative. When an imported component becomes risky, local suppliers receive investment. When a Chinese memory manufacturer cannot rely on foreign equipment forever, it has an incentive to qualify domestic machines even if they are initially less capable. Restrictions can slow technological progress, but they can also accelerate substitution. YMTC's planned IPO could pour much more capital into that process. Its parent wants to raise approximately 33 billion yuan, or 4 times $9 billion. Reuters says the money would be used for production upgrades and research into next-generation storage technologies. The company could be valued at as much as roughly $49 billion after listing. That would give YMTC access to another source of funding at exactly the moment when AI demand is improving the economics of memory manufacturing. This matters because memory is notoriously cyclical. When supply exceeds demand, prices collapse. Companies lose money, manufacturers reduce investment. Then demand recovers. Supply becomes tight, prices rise, and companies rush to build more capacity. AI has disrupted that cycle. Counterpoint says NAND revenue in the first quarter of 2026 exceeded the entire industry's revenue for all of 2023. That gives YMTC something Chinese semiconductor policy cannot create by itself: profit. Government support can build factories, but strong commercial demand can make those factories sustainable. This is the same dynamic that helped other Chinese technology industries scale. Electric vehicles are a useful comparison. China did not dominate EV manufacturing simply because it invented every important technology first. It created a huge domestic market, built supplier networks, scaled production aggressively, reduced costs, and improved products through repeated manufacturing. Memory could follow a similar pattern. YMTC already has enormous domestic customers. China has some of the largest cloud platforms in the world. ByteDance, Alibaba, Tencent, Huawei, and other companies are building AI infrastructure at massive scale. If domestic buyers increasingly use Chinese storage, YMTC can generate huge production volumes without immediately needing to dominate Western markets. That creates learning. More wafers mean more manufacturing experience. More experience can improve yields. Better yields reduce cost. Lower costs encourage more customers, and more customers create even more scale. This is the industrial flywheel that competitors should be watching. But there is an important complication. The global memory industry may eventually produce too much. AI demand has created shortages and high prices, but YMTC is expanding. Chinese DRAM manufacturer CXMT is expanding. Samsung, SK Hynix, Micron, Kioxia, and SanDisk are also investing. If all that capacity arrives after demand growth slows, memory prices could fall sharply. That would be good for companies buying AI servers. It would be painful for memory manufacturers. This makes YMTC both a beneficiary of the current AI boom and a potential source of the next supply shock. There is another limitation. NAND is not the most strategically glamorous type of AI memory. High bandwidth memory, or HBM, is the memory placed extremely close to AI accelerators and is critical for feeding GPUs fast enough during training and inference. That market is still dominated by companies such as SK Hynix, Samsung, and Micron. YMTC's strength is primarily NAND. China therefore has not solved the entire AI memory problem. But that distinction may become less important as AI infrastructure grows. HBM handles the fastest data close to the processor. NAND stores the enormous ocean of information surrounding it. An AI system needs both. The processor is the engine. HBM is the fuel line. NAND is the giant storage tank. Building a domestic AI industry means securing every layer. This is why YMTC's IPO is more than a financial event. It is another sign that the AI race is spreading beyond GPUs. The first phase of the AI boom made NVIDIA the center of attention. The next phase is exposing bottlenecks everywhere else: electricity, networking, cooling, transformers, optical connections, memory, storage, and every bottleneck creates a new strategic company. For China, YMTC may become one of the most important. The company was restricted. Instead of disappearing, it expanded. Its market share increased. Its technology improved. Its factories multiplied. And now the AI boom is giving it the strongest demand environment the memory industry has seen in years. That does not mean American export controls have failed. They still make access to advanced tools more difficult and increase development costs. But the long-term outcome may be more complicated than simply slowing China down. The restrictions are also forcing Chinese companies to build alternatives. If YMTC successfully raises billions of dollars, doubles capacity, continues increasing domestic equipment usage, and captures more of China's exploding AI storage demand, then one of the clearest results of the chip war could be something Washington never wanted: a Chinese memory champion that needs the West less every year.